Hi, it's Mrs. Harmison here with your Section 4C chemistry notes on gas laws. We need to learn about the units that are used for measuring pressure. One of the units for measuring pressure is ATMs, or atmospheres. If you're standing on the earth, you have 1 atmosphere of air above you. This unit of measure has to do with where you are compared to sea level and how much of the atmosphere is above you. kPa stands for kilopascals, which also can be converted to pascals by moving the decimal. Kilopascals and atmospheres are the 2 SI units for measuring pressure. PSI stands for pounds per square inch. This is a common unit for measuring pressure in the United States. For example, when you air up your tires in your vehicle, you would air them to a certain amount of pressure in PSI. Or if you look on a basketball or a volleyball, you'll see that it tells you how many pounds to inflate it to, and those measurements are in PSI. Torr and millimeters of mercury are both also units for pressure, and they are equal to one another. It is important to be able to convert from one unit of pressure to another. We have to have a conversion factor. On your periodic table, there's a box that looks like this, and it has the different conversion factors for the different units of pressure. To convert from kilopascals to atmospheres, we first start with our given number and unit. So we start with 104.3 kilopascals. We're going to make our picket fence. Whatever unit is here has to go down here. So we put kilopascals on the bottom right, and then we look up to our conversion factors to see which number goes with kilopascals. Kilopascals is 101.3, so we put 101.3 there. We want to get to atmospheres, so we put ATM up here, and we look and see what number goes with that, which is 1. And so we would take 104.3 divided by 101.3, and we get 1.030 atmospheres. Let's try this other one. 720 torr, 760 torr, and we're trying to get to PSI. PSI is 14.7, and so we will take 720 times 14.7 divided by 760 to get 13.9 PSI. The other conversion that you'll need to know how to do is to go from kilopascals to pascals. If we had a pressure of 112 kilopascals, to get from kilo to unit, we'd move 3 to the right. So that would be 112,000 pascals. Or you could go from pascals to kilo pascals by moving 3 to the left. We also need to know how to convert temperatures. You only need this one formula. If you have degrees Celsius, you add 273 to get Kelvin. So to convert 22.5 degrees Celsius to Kelvin, we add 273 and we get 295.5 Kelvin. If you have Kelvin, to get to Celsius, you'd subtract 273. A lot of times in gas laws problems, you will see the abbreviation STP. STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius, which is the same as 273 Kelvin. Standard pressure is 1 atmosphere. Standard pressure is also equal to any of these values. This is the ideal gas law. In the ideal gas law, P stands for pressure, and the pressure when you're using the ideal gas law has to be in either kilopascals or atmospheres. If you have pressure given to you in a different unit, you have to convert to one of these. For the ideal gas law, the volume has to be in liters, and then N stands for the number of moles, measured in moles. R stands for something called the gas constant. If your pressure is in kilopascals, R equals 8.31. If your pressure is in atmospheres, R is 0.0821. Each of these is a constant, and you use the one that matches up with the units that you have for your pressure. And then T stands for the temperature, which has to be in Kelvin. This is the combined gas law. P1 and P2 both stand for pressure. There's no specific units that you have to have, but they have to be the same. If you put atmospheres in for P1, you have to put atmospheres in for P2. The same with V1 and V2. Volume for the combined gas law can be in milliliters or liters, but you have to have the same volume for V1 as you have for V2. N1 and N2 both stand for moles. measured in moles. T1 and T2 both stand for temperature, and this is the only one that's very specific for the combined gas law. The temperature has to be in Kelvin. So if you have Celsius, you have to convert to Kelvin. When you're using the combined gas law, if any of the variables stay constant, you can put 1 in for both of them, which basically just means you can cross them out. When you're trying to decide which formula to use, the first thing you're going to do is make a list of your givens. Then, if there are 2 of any of the givens, pressure, volume, moles, or temperature, you are going to use the combined gas law. If there are just 1 of each, then you will use the ideal gas law. Okay, to do this problem, we're going to start by listing our givens. We have 857 liters, which is a volume. We have 15.9 degrees Celsius, which is a temperature. We have 755 millimeters of mercury, which is a pressure. Then it tells us it's released and rises to an altitude of 8.43 kilometers. Now, nothing in any of our gas laws indicates meters or altitude, so let's just leave that. That's likely extra information, but let's keep reading. Where the pressure is 296 millimeters of mercury. So we have another pressure. Anytime we have more than 1 of any given variable, we're going to use the combined gas law. So we're going to call this pressure 2 and this pressure 1. And then that makes this temperature 1 and volume 1. And then our new temperature here is going to be temperature 2. And we're trying to find the volume of the balloon at this new altitude. So V2 is going to be what we're trying to find. Okay, so we have all of our variables listed. We know we're going to use the combined gas law. All right, and now we have to look and make sure that our units are good. Liters are a good unit for volume, so our volume 2 is going to come out in liters. Celsius for temperature is not good for putting into any gas law, so we have to convert to Kelvin. And millimeters of mercury is an okay pressure unit, as long as the other one is the same, and they both are the same. So now we're ready to plug things into our formula. And then we do the math, solve for V2, and we get 1,808 liters. All right, this problem says a sample of argon gas occupies a volume of 6.6 liters at 56 degrees Celsius, which is a temperature, and 1.11 atmospheres, which is a pressure. If it is desired to increase the volume, so now we're going to have V2, so now this is V1, T1, and P1, to 8.81 liters, while increasing the pressure to 1.50 atmospheres, the temperature of the sample at the new volume must be what in Celsius? So we want a temperature in Celsius, but we have to solve for it in Kelvin, so we have to convert this number to Kelvin, and we get 329 Kelvin. We're going to use the combined gas law. We don't have any moles, so we're going to cross out the moles, but then everything else we're going to plug in. And then we solve for T2, and we get 593 Kelvin. But our answer wants Celsius, so we have to subtract 273 from the temperature in Kelvin, and we get 320 degrees Celsius. All right, this problem says we have 1.02 moles, so we're going to say N equals 1.02 moles of xenon at a temperature of 15 degrees Celsius, and it's found to occupy a volume of 25.7 liters. The pressure is what we're looking for, and it wants that pressure in millimeters of mercury. So we don't have any duplicates here, so we're going to use the ideal gas law, PV equals nRT. For the ideal gas law, we have to specifically check the units. So the pressure cannot be in millimeters of mercury when we put it into the ideal gas law. We have to pick either kilopascals or atmospheres. And then we have to choose our R based on which one of these we pick. So let's pick kilopascals this time. The R for kilopascals is 8.31, and we're going to plug that in for R. For temperature, we can't have Celsius. We have to change to Kelvin. Volume is in liters, so that's good. And again, our pressure is going to come out in kilopascals, and then we'll convert to millimeters of mercury. We will plug things in. We solve for P, and we get 94.99. Again, because we have 8.31 as our R, it's going to be kilopascals. So we now need to convert 94.99 kilopascals to millimeters of mercury. We get 713 millimeters of mercury.